Hi everyone, sorry for the long delay, but finally we're ready to go. I hope it keeps working until the end. So you're in Bitcoin and Decentralized Apps 101, build your own digital currency. So I hope you're in the right session, but let's get started. So a little bit about me. My name is Márcio. I'm originally from Caruaru, Brazil, and I'm a computer science student at Macalester College. And a little fun story about how I started. I became interested in Bitcoin. There's actually this guy on YouTube called Siraj Raval, and he has videos about mostly everything, like artificial intelligence, decentralized apps, like literally everything. And I watched one of his videos about decentralized apps, and I decided that it was going to change the world. So I decided to learn more about it. And actually, I decided to give this talk here at Minibar today because, like, as a way to force myself to learn more about it. So we'll see how it goes. So a brief overview of what we're going to do. We're first going to be talking about Bitcoin, the blockchain, decentralized applications in general. Then we're going to look at Ethereum. Then we're going to build and test Minicoin, if we have time. And then we're going to talk about some next steps if you want to move on, like building your own decentralized apps. Okay, so let's get started. So as a show of hands, who here knows what Bitcoin is? I'm hoping most everyone. Okay, good, sounds good. And who here thinks they can explain exactly how Bitcoin works? Okay. All right. So Bitcoin is basically it's a decentralized digital currency, right? So like think the U.S. dollar, but with no physical copies, right? It's all digital. It's all digital. And it is actually the most popular decentralized application out there right now. It's the first. It's not quite mainstream, but some people say it's the first mainstream decentralized app, which I don't quite buy. But anyway. And so it was introduced in 2008 by some person named Satoshi Nakamoto, and like who that person is to this day, we have no idea. We don't ever know if we're gonna find who he is anyway, or she is. I don't know. And one Bitcoin is it's currently worth about $900. Like only a few weeks ago, I think it was worth like what 1,300, and then yeah. So yeah, it's been falling kind of recently, but. Yeah, and it's actually the largest currency in terms of market value out there. They actually have about 70% of the market cap, which is crazy to think that it's like, and that 70% of the market cap is actually the lowest number that Bitcoin ever has, which is crazy to think that like 70 is the lowest market cap that they ever had. They're used to being in the 80 to 90 range. So who uses Bitcoins, right? You know what they are? Who uses them? So Bitcoins can be used to exchange currencies, products or services, and there are two big groups of people, big groups that use Bitcoins. One of them is like there are hundreds of thousands of online marketplaces that accept Bitcoins. You have a list of them over there, and one of the main advantages for them is that credit card processors they charge a 2 to 3% fee for every single transaction, but for Bitcoin they only have to pay from 0 to 2%, so it's a little bit cheaper. And then another like big market for Bitcoin is the dark net. And if you don't know what the dark net is, we're going to talk about that a little bit later, like why Bitcoin is good for the dark net, but we don't have time to talk about the dark net itself. But anyway, so how does Bitcoin work? So Bitcoin is a peer-to-peer system where users can exchange their Bitcoins directly with each other. So if you think about a classic client-server architecture, like think Facebook, for example. If you wanna do something with Facebook, if you wanna send a message to a friend on Facebook, your computer doesn't send the message directly to your friend's computer, right? Like it has to go through a central server and all that kind of stuff. So that's your classic client-server architecture. Bitcoin instead uses a peer-to-peer architecture where every node, each computer is connected to every other computer, right? So when you want to send something, if you want to send Bitcoins, you send them directly to the person that you're trying to send it to. Like there's no middleman. A little caveat of that is that you have to broadcast that to all the networks so that they can do a few security checks and all that kind of stuff. But the money actually goes directly from your computer to the other person's computer. And as a side note, what are the advantages of decentralized applications? So a big one is that they're always available. There's no central point of failure because, for example, if you're the Chinese government and you want to shut down Facebook, you have to shut down only a few central servers. And if you do that, Facebook doesn't work anymore. But if you have a decentralized app, there's like, well, potentially thousands of computers that we would have to shut down, like in different locations and all that kind of stuff. It's just much harder. Because if you think about that graph that I just showed, if you eliminate one node, all the other nodes are still connected to each other. So there's no central point of failure. They're going to keep going. And that leads us to the second one. It can't be brought down by any one entity. So like it becomes really hard to have any sort of censorship. And if you've heard of Bitcoin before, you've probably also encountered the term blockchain, right? So what the blockchain is, the best analogy that I found to explain what the blockchain is to think about a game of poker. So imagine that it's the weekend and you invite a few friends over to your apartment and you want to play poker. But once they all get there, you actually realize that you don't have poker chips. Like, right, you can't play without them. And then you have an idea, oh, I could just use like cash, right? I could just use like physical money. But then you look around the table, you ask around, like no one has cash either. So how do you deal with that situation? So one solution to that is to all of you, or at least a few of you, take out a piece of paper and you write down all the transactions that happen in a hand, like in a, what's it called? No, in a round of poker, like a hand, yeah. Okay, yeah, there we go. So you write every transaction that happened in that hand, right? So for example, like Masio bets $200, someone else bets that like certain amount, and then at the end of the hand, you compare everybody's notes and you make sure that they're all in sync, right? So make sure that no one cheated, basically. So basically, that's a very like simplified description of how the blockchain works. But the idea is that the blockchain is just a global ledger that records every single Bitcoin transaction that has ever happened. So if you think about it, like sending Bitcoins is basically just writing something on a ledger. So something like Masio sends Francesco 5 Bitcoins or something like that, right? That's all that it takes. And so going back to our poker analogy, like it's basically just the same thing as just like, whoop, no. Oops, there we go. Now I gotta bring that back. In a second. There we go, okay. So, so sending Bitcoins to someone else is just basically writing something on the blockchain, which is just a global ledger that keeps track of everything that has ever happened. Okay, I think I'm done with that slide. So who are these people who are taking notes and recording everything on the blockchain, right? So for Bitcoin and for, I guess, like all the kinds of decentralized applications, they're called miners. And the general idea is that some people are just exchanging money. Some people are just using Bitcoins, and some people are actually like keeping track of the blockchain, like keeping it up to date. And these people are miners, and they actually they volunteer for that. Oh, okay. Okay. So miners, like anyone can volunteer to be a miner in the block for Bitcoin, and you spend like thousands of dollars in electricity and computing power to do that, and we're going to talk about that later. Basically, the idea is that these miners are like volunteers that keep the blockchain updated so that everybody else can use it. And so what keeps Bitcoin safe? And the answer to that is cryptography. So cryptography is basically, it's used to make sure that no one can fake your identity and send money on your behalf, at least for Bitcoin. And it does that through keys, right? So keys make mathematical guarantees about a message. So something like saying, hey, this message is actually coming from me, not from someone else. And in order to understand how that actually works for Bitcoin, we have to understand the concept of wallets. So all that wallets are, they're apps that let people create and manage an account on the Bitcoin network, and that they also allow you to buy and sell those accounts, or to send it to someone else, right? So basically, in a way, just like a physical wallet. And the idea is that every time they create an account in one of these wallets, you get a public key and you get a private key, right? And so Bitcoin uses public key cryptography to generate what are called digital signatures. So the general idea of digital signatures is that you use your private key, which your wallet helps you store locally, like wherever you have your wallet. Like like for example, if you have it on your computer, it's going to be stored locally, and it's going to be like password protected and all that kind of stuff. There are many layers of protection. So you use that private key to sign the data that you're trying to change to send to the network. So let's say you want to send a transaction. Masio sends Francesco 5 Bitcoins. I sign that that data with my private key, and then that needs to be verified by the miners, who are going to be the people writing something to the blockchain. And those miners are going to use my public key to check that the private key is, to check that the message came from me, because the idea is that the private key and the public key are related to each other. So if I actually send something through my private key, then my public key should check out. And if that happens, then a transaction is added to the blockchain. And okay. So what happens when a new block needs to be added to the blockchain, right? So to earn the right to add a new block of transactions, miners, they basically compete, they basically run to solve math problems created by a cryptographic hash function. And whoever solves that hash problem first gets to add the next block to the blockchain. And the reward for that is that when you get to add the next block to the blockchain, you get 12.5 bitcoins that are actually created out of nothing. They weren't there in the network before. So they're created out of nothing, and they're awarded to the miner who won that race. And actually, fun fact about that is that actually started because the amount of bitcoins that can possibly exist is actually finite. There's only 21 million bitcoins that could possibly exist. Not all of them are out there right now because they're still being created. But the idea is that the reward for miners actually goes down over time. So it started with 50, and it actually halves over time. Like I forgot the exact number, but every few blocks, it goes down every four what?
4 years.
Every 4 years? Oh, I thought it was by number of blocks. Okay.
Yeah, it's based on the number of blocks, and they didn't think
Oh yeah, right. Yeah. Okay. Yeah. So about 4 years, they get half. So it started with 50, then it went to 25. Now it's at 12.5. Then it's going to keep going down. So yeah, like the cool thing is that each Bitcoin that ever exists was created to reward a miner, which is like just something that I think it's awesome about Bitcoin. And miners are called that because they hope to strike it rich, basically, right? They're just like trying to solve these problems as fast as possible so they can add the next block to the blockchain, and if so, they're gonna get some money, right? So that's why they're called miners. But the idea is that so hash functions. Well, for the sake of time, since we're so late already, I'm gonna explain what hash functions are. I'm gonna skip the summary too. So yeah, let's talk about who controls Bitcoin. So Bitcoin basically has no central authority. It has no, like, since it's decentralized, there is really no central authority who like controls anything, like who's in charge of like deciding how many Bitcoins are gonna get created and all that kind of stuff. There really is no authority capable of doing that, which is like kind of a bit of a foreign concept if you compare it like to a normal currency in a way. And oh no.
Isn't there a concern that there's a kind of a central or some miner has almost 50% of the computing power for generating these bitcoins? Is there something that theoretically, if
51% attack,
Yeah. I mean, I guess like that's kind of hard to do just because there's so many miners out there and you need so many resources in order to actually control 51% of the whole thing. But it would be, if it actually happened, then it would be a pretty bad thing.
Yeah, so
Yeah.
it could happen without 51% per se. If they get 6 blocks in a row, they could, in theory, if they could reliably get 6 blocks in a row, they could do a double spend attack, which has actually been done on Ethereum clones that have been spun up. Not Ethereum itself, but the Coinbase is based on Ethereum. Have been attacked by miners because their hash power was so low on the network that they've basically been DDoSed. But Bitcoin is fairly resilient, and the network has been to date self-reassembling. So if a pool knocks out or gets close to knocking out 6 blocks, the miners, the people that are hashing, will voluntarily disconnect from that pool.
So what gives Bitcoin's value? Basically, there are a few things. Well, first of all, other people spend it. Like, other people use it too, so you can spend it to pay things with them. Second of all, it's really hard. So like going back to the darknet right now, it's really hard for the government to trace that money and tax it. So if you're in the darknet trying to buy some illegal stuff, then like that's really attractive to you, right? And some people see it as an investment too. Like they buy it just like stock, kind of. They hope it's going to grow up, so they buy it for a lower amount, try to sell it for a higher amount, try to get some profit. So that's it for Bitcoin. And once it comes back, we're going to go to Ethereum. Right. So what Ethereum is, it's a platform that lets developers build decentralized applications and blockchain-powered applications. And so it has a network of computers and miners just like Bitcoin that you can use. And anyone can write and run programs on the network. And you basically only pay for what you use. So basically, if you're trying to, and you do that through smart contracts, which actually is the next slide. So that code is what is known as smart contracts. And smart contracts, for our purposes, they have different definitions. But for our purposes, it's just like code that can be stored on the blockchain and it can be executed and verified by other nodes, right? And so by doing that, you can. I don't even know why it's doing this. I'm not even touching the computer, but.
It's been doing it all day.
just gonna keep going for now. And it's permanent and resistant, just like the blockchain that it lives on. Like you can't, like, once you write it down, basically, like no one else can like change it, kind of. And yeah, we can add different kinds of functionality to a blockchain through smart contracts. I was gonna go through like what these companies are doing, but I don't think we have time. And in Ethereum, these contracts are usually used. They're usually written in a language called Solidity, which we are getting. Okay. I'm just gonna keep going without the slides for now. So Ethereum has their own currency, and it's called Ether. So it's basically the same idea as Bitcoin. And the idea is that when you're using a decentralized application, and whenever a transaction happens, you need to pay a transaction fee, just like Bitcoin. And that transaction fee inside of Ethereum is paid through Ether. So basically, if you want to use Ethereum, you kind of have, as of right now, you need to have some Ether to like spend whenever you do a transaction. They want to change that on the next version so they can use other kinds of tokens too. But as of right now, you actually have to own some Ether. And so, as for the current state of Ethereum, the number of daily transactions is actually now higher than Bitcoin's, not necessarily because everybody's exchanging currency like with each other and all that kind of stuff, which is the only use case of Bitcoin per se, but actually because there are just like so many apps built on Ethereum, and if you want to use them, you need to, if you're going to write something to their blockchain, you need to spend some Ether, and therefore the number of transactions is already higher than Bitcoin's. The price of Ethereum has actually also experienced like a recent surge. I think at the beginning of the year it was $15. Right now it's over 50. And there's a growing number of industry adoptions everywhere. So now, if my computer wants to show things, then we will take a look at some code. Okay. So, sure, 6 minutes. And that's too big. Go down. All right, so basically, this is a smart contract, and it basically works just like a class. If you've taken if you are a programmer, it basically works just like a class, and you define the contract just like you would define a class. In this case, my contract is called Minicoin. And here I have some variables like name, symbol, decimals, total supply, all the kind of stuff. And then this over here is basically the initializer function. So when you publish something, I just wanted to initialize those variables, kind of. So initially, all the initial supply goes to the person who deployed that app, in our case. And then I send it a name, decimal units. I'll show you how to deploy something later. I skipped the balances. So basically, the balances is basically like a dictionary. It maps someone's public address on the blockchain to their balance on Minicoin. There we go. And then you have a few functions that decide like what kind of transactions can happen for this app. The main function over here, of course, is the send coins function that allows you to send some amount of mini coins to someone else. Basically, you need to have their public address from the blockchain. And then, so this over here is basically just like a few checks to make sure that you have enough balance to actually send money, or that there's no overflow, or that your account is not frozen. If that is, we're going to throw an exception. We're going to exit. Otherwise, it just decreases the amount of your account, decreases your account by that amount, and increases someone else's by the same amount. You can see like this only owner. It means that only the first person. So the way that I have set it up right now, the owner is the person who published the contract. So whenever you publish the contract, the owner variable gets set to your public address, and then you become the owner, basically. You can transfer the ownership very easily. I don't think I implemented this this time, but you can transfer the owner. You can definitely transfer it. But anyway, so the only owner means like exactly what it says. Only the owner can run this function. If anyone else tries to run it, it's not going to work. And so mint is just if you want to increase the amount of coins there are out there, or if you want to decrease it, you call the mint function. You send the amount that you want to increase it by or decrease it to. The freeze accounts basically just adds someone's address to frozen accounts, which is just like a list of all the frozen accounts, so people can't really like once your name is out of there, then you can't. Once your public address is out of there, then you can't really send any money to anyone else. And last but not least, we have the buying functions. Basically, they let the owner set the buying price and the sell price. And the way that the buying and selling works is that So if you want to buy some mini coins from me, what would happen is, oh, and also yeah, since I deployed the contract, all the mini coins are on my account, right? And if you want to buy some mini coins from me, basically what happens is you send me some ether, and then based on the buy price and the sell price that I set, in this case based on the buy price, you send me some ether, and then I calculate how many mini coins I'm going to send to you, right? And then I send those mini coins to you, and all of a sudden you have that. And then the sell just works the opposite way. You want some ether back, and then you send me the mini coins, and then I translate that to ether, and then I send you back some ether. So yeah, if the computer works, we can do a demo. But yeah, I don't even know. Okay, well, I don't think we're gonna have time for a demo. I'm sorry. I'm gonna post the code on GitHub if you guys want to look at it. But basically, the general idea is that if you wanted to publish, if you write a smart contract and you want to publish it, there are multiple ways to do it. There are a few frameworks. There's a framework called Truffle, which is really good. They have good documentation, so I recommend you guys take a look at that. And there's also another framework called Embark. They both do the same thing. Just Embark is like a little more recent, so it doesn't have that much documentation yet or support. But yeah, so like basically you would use those frameworks if you want to create like a front end for your app. If you don't really care about a front end and you just want some sort of, oh nice, okay, let's try to do this. Ooh, let's try to do this. So basically this is the Ethereum wallet. So like I explained what wallets were before, and this is the Ethereum version of it. Let me make this bigger. I think, okay. So basically I have a few accounts. Let me go back to my wallet. I have like a few accounts. This is the main one, has some ether on it. And when you want to publish a contract, like the one that I wrote, you come over here to contracts, deploy new contract, and then you copy and paste that code. I have it here right now. I actually already published one because it actually takes a little while for it to be actually published on the blockchain, and then for you to download the last version of the blockchain so everything is set up. So I already published it actually. But all that you would do is you would just deploy it, and then it would be live. So let's go back to the contract. So this is the contract. This is like a little admin page. So basically, like, yeah, you would use a framework if you want to have some sort of like other admin page, or if you want to create like a user interface where users can interact with your app. But basically in this admin page, since I'm the owner, I have access to all the functions over here. So you basically like select what function you want, for example, send coins. And I would like, in this case, I would need the address of the person I want to send the coins to. So I'll try to do it. It might take some time, but so I'm going to get that address. And then try to send some coins over there. Let's say that much. And then you just execute. Oh, okay. Need your password. So basically every transaction that you ever have to do, you have to input your password, just like another layer of security. So you input your password. For what? Wrong password, okay. Oh, right. Okay, so you see the transaction sent, but, so, I mean, here at the bottom, like you see, like you basically see your current block number, like where in the blockchain you are. And I'm waiting for it to get updated so we can check that the money actually went to this person. But, okay, so first of all, the balance before was this. Yeah, this is the balance that belongs to that person. And once it finally gets updated, you would see, I don't think we have enough time for it right now, but you would see that would get updated, and they would get whatever this is. So yeah, you can actually pay a higher fee so that the transaction goes a little bit faster, or like you can just like set the default, which takes about like a minute or so. But yeah, I mean, I will demo the other functions too, but I think we're running out of time, so. So yeah, I'll open the floor to questions if anyone has any. Back there.
So your Minicoin is not like a peer to Bitcoin. This is like
No.
an example of a contract on Ethereum.
Yeah, yeah. Mm-hmm.
What are some other kinds of contracts that get executed on Ethereum? Are they all like currency like things?
No, like so another like a really cool one, like basically like Minicoin is basically a token on Ethereum, and a token can represent many things. So there are some people who use tokens, for example, to represent shares in a company, right? So like Yeah, in this case, like the idea is that I'm sending. I guess like you could actually use most of this code because like you would, if someone buys shares from you, you would send them their shares and all that kind of stuff. But like, yeah, you could use it for shares. There's actually some people who are using it to tackle like online voting, which is like really cool. I think I'm not 100% sure if that would like if it worked quite as well as they wanted to be used, but like. Yeah, some people are using it for that. You can also build what's called there's people who are like building social networks with it too. There's like a lot of applications that could happen with them. And if you want to like more detail on it, I guess, like how to publish, like not to publish, like how to build different kinds of smart contracts. They're not exactly currency-like. I would recommend just going to the Ethereum.org website. They have a few like tutorials about like building a decentralized autonomous organization, which is really cool. Yeah, they have a bunch of tutorials there, so you can take a look at those.
I've never used a smart contract before.
Okay.
Does it just automatically generate like that basic UI? Like how flexible is that?
So this UI,
Yeah.
this UI actually comes from the Ethereum wallet. So it's smart enough to know like to kind of map your functions to a UI. Like in a very simple manner, right? This is like the simplest admin panel they could possibly have out of that. But yeah, like in this case, if you use their wallet, if you just publish to their wallet, then yeah, like that's all the UI they can have. But once again, if you use the frameworks that I told you about, like Truffle and Embark, then you could actually tweak the UI to like basically be whatever you want. Yeah. Yeah, you can definitely, yeah. Yeah, there's like a Heroku for decentralized applications kind of, so you can like put it over there.
Would you be able to do it outside of
Yeah. Like, the same thing. Like you would use one of the frameworks for that. Yeah, I was actually gonna do it with a UI too, but like I thought it was overkill for the whole thing. But yeah.
So I think you said, and I'm still new to Ethereum, but you said you had to spend some Ethereum to publish your contract. How expensive was that?
It depends. Let's see how much it would cost over here. So basically, it calculates what? Oh, okay. It kind of like calculates how like the weight of your contract, kind of like how complicated it is or whatever. And then like it kind of selects you a fee, but like you can change the. Oh, you guys can see it. Okay. Basically, there's a slider over here, and like you can select the fee. If you pay a higher fee, then it's gonna get faster. But like the fee for this contract, I paid 0.02 Ether, I think, for it. So like at the end of the day, it's not that expensive to publish it. Like, but and again, like the faster you want things to go, the more you have to spend.
Yeah, but like, do you have to pay that every time you do something with it, or just the first
If you
time you put it out there? Or how does that work?
So yeah, so when you deploy a contract, then you have to pay it once to just like kind of put it out there, and then after that is like every transaction that writes something to the blockchain, so sending money, buying something, all that kind of stuff. Every transaction like that, you also have to pay some like a fee. But like the person who pays the fee is the person who makes the transaction, right? So it's not always you.
Is it related to the contract, or is it just a sort of a small amount?
It's a small amount. Yeah, it's not. I don't think it's set by the contract. Maybe you can. I know. I can't set it here from the Ethereum wallet. Maybe you can set it with the frameworks, but I'm pretty sure. I don't think you can set it. I think it's like, you can set the. I think you can give people options. Like if you build it with the framework, you can give people options like, oh, like do you want to send it faster or slower, all that kind of stuff. But yeah, but you can definitely do it if you want.
Is there just like one Ethereum blockchain and that's what everyone uses, or are there like other ecosystems, like maybe you didn't need as much security or reliability and you wanted to start your own blockchain that it would cost you?
Mm-hmm. Yeah, actually, I'm pretty sure that for Ethereum, like it's a single blockchain everybody else uses. That's basically why you have like 3 million and whatever blocks. It's a lot of them. And I'm actually not 100% sure like competitors to Ethereum, like if there are other.
They have test nets, like they have.
Yeah, they have.
Official, you know, like it's the same as Ethereum, only monopoly.
Also forfeit too. You can clone it and forfeit and use it as your own blockchain.
But no one else
Yeah.
will be running compute on it, so like.
Yeah, exactly. Yeah, that's the problem. Yeah.
So forth, you know,
Yeah, that's one of the biggest advantages of like running something on Ethereum is because that infrastructure is already there, you know, like the miners and all that kind of stuff. So, I mean, but I guess, yeah, if you wanted to create your own, like, you could definitely do it. But, yeah, you need some infrastructure for that.
There are also frameworks like Hyperledger and like other.
Yeah. Mhm. Yeah. Anything else?
Can you, like, what's sort of the range of things? Like, you can, I've heard about creating tokens. I've heard about how you can sort of use that for voting. So any application like a token. But what else can you write smart contracts for? Like, is it always kind of that? Is it always sort of transactional stuff like that? Or
Yeah, like since they basically run on like a blockchain, like the idea of a blockchain is basically like writing transactions. So it has to be something kind of like that, yeah, something that you kind of write transactions on.
It's a finite state machine.
right.
Yeah.
So it's really, it's basically, it's a glorified FSM, and it reacts to transactions. So when a transaction is an account, that triggers the code to execute, and it's pay to play, so it prevents you from doing things like infinite loops, right?
Oh,
Mhm.
right. Right.
They don't burn it down.
Right, this is the slide that I told you about. Like if you, oh, then it's gone. Yeah. But anyway, it was down there. You pay a higher fee to make things faster. But yeah. Any other questions? All right, thank you guys. Let's have some beer.